Today we will discuss about dye-sensitized solar cell. What is dye-sensitized solar cell? Why we call it dye-sensitized solar cell? What is the mean of the dye in dye-sensitized solar cell? What is sensitizer? These are the outlines what I am going to discuss with you all. Why dye-sensitized solar cell? What are the background of dye-sensitized solar cell? What are the construction and the working steps? Also, I will discuss about the performance curve of the dye-synthesized solar cell, use of the natural dye in place of organic dye, which affect the dye-synthesized performance too much. And what are the limitations of the dye-synthesized solar cell and the future scope regarding this. As we know, with the rapid development of the economy, our Earth community requirement for energy is rapidly growing. All the aspects of the human life are affected by the internet technology, and all this technology greatly affect on the share of electricity faster than the total primary energy supply. And this is shown by the World Energy Scenario 2050. The shows that 76% of the data, 76% of the energy is consumed by fossil fuels, and unfortunately, each step of extraction, transportation, and all such things regarding fossil fuels is very harmful to human health as well as to our environment. Therefore, it is the basic requirement to achieve an alternative source to that of the fossil fuels, which is supportable and clean to take off fossil fuels. And we know it is the solar energy, which is immense fresh, clean, and malleable energy to various needs. Solar energy is the alternative of the fossil fuels. And we know in 1954 the first solar cell was assembled in Bell's lab with 6% of the energy efficiency, and it was proclaimed commercially with 2% of efficiency in the market. Further, for commercializing purpose in 1989, a new class of solar cell is represented which gives about 10% of efficiency is reported at University of Delaware. This class of solar cell was named as thin film class of solar cell. Further, to enhance the efficiency of the solar cell and for the commercializing purpose, which is economically alternative, economically credible to our society, Michael Gurdjieff and Orezan will develop a very new kind of the solar cell that is called dye-synthesized solar cell. This dye-synthesized solar cell uses a dye as a photoactive material. Now I will discuss about what is dye-synthesized solar cell. Why we call this dye-synthesized solar cell? What is the dye? Basically, dye is the key component of this dye-synthesized solar cell, and it is the dye which is responsible for maximum absorption of the sunlight in the solar cell. And sensitized, here it is to be mentioned here that it is sensitized, not synthesized. Sensitized means that is a photoactive material, active material. The dye is only the photoactive material which is responsible for absorption in the solar cell. It is economical, credible alternative of conventional p-n junction silicon devices. In 1960, it was principle that electricity can also be through that organic aluminum dye in electrochemical cells. A dye-synthesized solar cell is a very low class of solar cell, belongs to thin films of group of thin film solar cell. This is third generation solar cell. And the first chlorophyll sensitized zinc oxide electrode was synthesized in 1972 with efficiency, of course its efficiency was very low, about to 1%. For this reason it is very difficult to commercialize it in the market. Further, research were ongoing that will enhance the efficiency of the dye-sensitized solar cell up to 7% of the efficiency. Since this dye-sensitized solar cell was discovered by Michael Gladgel, therefore we also call this dye-sensitized solar cell the Gladgel cell. The basic advantage, the basic motivation towards dye-sensitized solar cell is that this solar cell can be used in even in diffuse sunlight or in cloudy condition. This solar cell performs good even in slow light, even in low light condition. And there are many type of solar cell: cadmium telluride, GS solar cell, perovskite solar cell. Perovskite is of course the next generation of the dye-sensitized solar cell. And conventional silicon solar cell, dye-sensitized solar cell overcome as the research were resulted into large efficiency regarding the to work on the conventional silicon solar cell. Then dye-sensitized solar cell will emerge as a very new and interesting alternative to the conventional silicon solar cell, and of course it will be very economical, credible to our human society. This is the construction of the dye-sensitized solar cell. It is comprised of transparent counter electrode, transparent working electrode, and it is sealed to a hot melt tape to prevent the liquid electrolyte. And this is the construction of the dye-sensitized solar cell. Now I will discuss about what the basic component regarding the dye-sensitized solar cell material. What are the basic material? A dye-sensitized solar cell requires a highly transparent substrate for optimum passage of the sunlight to the effective area of the cell. And the substrate should be high electrical conductivity. That's why we use fluorine tin dioxide, indium tin oxide as a substrate in dye-sensitized solar cell material. Nowadays we use titanium dioxide, zinc oxide, SnO2, anti-p-type material as fluorine tin oxide as a substrate material. The basic property regarding all the oxide material or metal oxide material, this is called window layer. The basic requirement regarding the window layer is that the oxide should have a wide band gap of energy about to 3 to 3.2 electron volts. And we use this, why we use the titanium dioxide mostly because it is not dioxide, it is less expensive and easy availability of the titanium dioxide make it large useful in dye-sensitized solar cell. Nowadays we also use carbon sensitized graphene titanium dioxide composite photo anode as electrode in solar cell. Now what is dye? Why this solar cell is known as dye-sensitized solar cell? This is the basic component of this type of solar cell, and this dye, after imaging the working electrode in a mix of photosensitizer, that is dye is a photosensitive material and it is responsible for absorption of the sunlight. After immersing with working electrode and with a solvent, dye get covalently bonded to titanium dioxide surface, and due to high porous structure and large surface area of the electrode, large number of dye molecules if attached to the titanium dioxide surface, large number of photons will be absorbed, and that will be lead to a larger efficiency of the dye-sensitized solar cell. And dye is responsible for, as I told, it is maximum absorption for sunlight. Therefore, it is primary requirement that what we use the dye, what we select the dye, it should be luminant in nature, and all the absorption spectra of the dye should cover the UV, ultraviolet, infrared, and all to visible region of the electromagnetic spectrum. The dye must carry a carboxylate or phosphonate group to anchoring on the surface of the semiconductor oxide. And the periphery of the dye should be hydrophobic to enhance the stability of the cell. Further, what is LUMO? LUMO is the lowest unoccupied molecular orbital. Lowest unoccupied molecular orbital is at the higher energy state of the molecule. Because at the normal temperature, normally all the electrons remain in their home, remain in their home. Regarding their home is ground state, that is in at the normal temperature all the electron resides in their ground states. Therefore it is ground state is the highest occupied molecular orbital and excited state is lowest unoccupied molecular orbital. The lowest unoccupied molecular orbital of the sensitizer must match the edge of the conduction band of the oxide to minimize energetic potential loss during the electron transfer reaction. Further, I will discuss about the what is the conduction band, what is the valence band regarding the semiconductor oxide layer. Selection of electrolyte. Electrolyte is the basic component in the dye-sensitized solar cell. The electrolyte functions as charge carrier, collecting electrons at anode and transporting the same electron back to the dye molecule. And the redox couple we use as a dye should be able to regenerate the oxidized dye during the oxidation of the initial state efficiently. And the dye we select should have long-term chemically stable, electrochemically stable, and it should be coupled to non-corrosive with dye-sensitized component. It should permit a fast diffusion of charge carrier and to enhance conductivity and create effective contact working and counter electrode. The electron injection in titanium dioxide conduction band occur only in the femtosecond. That is what a very short span of time. Within a short span of time, the electron injection occurs in titanium dioxide electrode. Now we will discuss about the counter electrode. That the working electrode and counter electrode are sealed together, as I told. Therefore, the platinum is generally used as a counter electrode in dye-sensitized solar cell. It is sealed together subsequently and electrolyte is filled with the help of a syringe. Platinum acts as a catalyst for the charge transfer reaction occurring between iodide and triiodide ion. Counter electrode catalyzes the reduction of the liquid electrolyte. Till today we also use carbon forms like carbon nanotubes, functionalized graphene, mesoporous carbon fibers have successfully used as counter electrode to enhance the efficiency of the DSSC, that is dye-sensitized solar cell. Now what is the operational mechanism of the dye-sensitized solar cell? This is the points regarding this. Firstly, incident light is incident on the effective area of the solar cell and that is absorbed by the dye, that is photosensitizer, and the electron get promoted to the ground state to excited state. This is the reaction. First of all, this is the initial state of dye. This will absorb the sunlight radiation and that will lead to excited state, higher energy state. Second point is that the excited electron in the dye within a lifetime in nanosecond injected into conduction band of the nanoporous titanium dioxide. Now I will discuss further through this figure. This is a reaction regarding this. And the injected electron are transported between titanium dioxide nanoparticle and diffused back to the counter electrode and the work it utilized to add the load to the external circuit. This is the operational mechanism. First of all, I told that first of all light is incident on this effective area, and it is also to be mentioned that electrolyte in this type of solar cell, light can incident even from front area or to back area. Here we use front area incidenting on the photons. Light is incident on front area of the solar cell. Photosynthesis, that is dye electron in the ground state of dye get promoted to higher energy state and within a nanospan of time it is get injected into conduction band. Why it is get into conduction band? Because the energy level of the excited state of the dye and the conduction band of the titanium dioxide electrode are very slightly up and down. The titanium dioxide conduction band is slightly down to the counter electrode, and we know that dye molecule are covalently bonded to titanium dioxide surface. That's why the electron in the excited state of the dye molecule get injected into conduction band and the electron in conjunction band or platinum dioxide surface will diffuse in this electrode and goes to counter electrode. Work will utilize this load, whatever we use load as a fan, as a bulb, electric bulb, or any so on. After reaching electron at the counter electrode, triiodide is reduced into iodide ion, whereby the acceptance of the electron during this process, this oxidized dye goes to its initial state and the ground state, and the process remain as a feedback, like a feedback, and gives to our electricity. What are the basic parameters which define the performance of a dye-sensitized solar cell? This is the short circuit current density. What is short circuit current density? It is the current when produced when the positive and negative electrode are short circuited. That we can also say that when load resistance is met 0 millivolt, it is determined based on incident light harvest efficiency. What is open circuit voltage? These are the basic parameters of the performance to evaluation performance. Open circuit voltage. What is open circuit voltage? Open circuit voltage is across the positive and negative electrodes under open circuit condition. That is, they are not connected to each other. That is infinite. When they are not connected, infinite resistance exists between these two terminals. That is, open circuit voltage is the voltage when no resistance, when infinite resistance is attached at terminal. That is, current never flow. If the terminals are not connected, then current will not flow. What is the maximum efficiency? Maximum efficiency Pmax. Fill factor. What is fill factor? Fill factor is the ratio of maximum output to the product open circuit voltage short circuit current density. Incident photon conversion efficiency, that is known as IPCE, can also called quantum efficiency. It is the ratio of electron flowing through external circuit to number of photon incident on cell surface at a particular wavelength. Photon conversion efficiency determines the overall performance of any type of solar cell. It is the ratio of maximum electrical energy output to energy input from the sun. It is the product of this open circuit voltage, short circuit current density, and fill factor to the input power. What is incident on the effective area of the cell? This is the sample representing the performance, JV performance of a dye-sensitized solar cell. This is the point regarding open circuit voltage. This is the point regarding short circuit current density. This is maximum in current density. This is the maximum voltage achieved. Here the fill factor from photon conversion efficiency, power conversion efficiency. It is clear that if fill factor will be larger, JC will be larger, VOC will be larger, the PC will be of course larger. That's why if this curve become this type of a rectangular shape, that will lead to a high fill factor, high JSC, high VOC. That will lead to a high photon conversion efficiency, high power conversion efficiency of the shell. Now I will discuss about effect of temperature on the dye-sensitized solar cell. This is the graph regarding this. This graph reveals that initial voltages for all the variation of the temperature are 0. This shows that electron density does not increase by increasing temperature. However, the dynamics of the electron will increase. This variation of the temperature is performed at 275 Kelvin, 300 Kelvin and 325 Kelvin. Now I will discuss about effect of variation of intensity of the light. And this graph reveals that by varying the intensity, it will greatly influence the performance of the dye-sensitized solar cell. It will also lead to high JSC, high VOC value, and it also reveals that electrode voltages are increased by increasing intensity of the sunlight by increasing the significant number of the electrons in the electrode. Now, what is the effect of the absorption coefficient on this dye-sensitized solar cell? From this graph, it reveals that the absorption coefficient, that the performance of the dye-sensitized solar cell on the absorption coefficient is exponential in nature, and to see a significant change in the performance curve, we have to vary the absorption coefficient by the order of 10 to the power 3, that is varied by this. Now what is the variation? Get the variation of the thickness of the electrode layer. This reveals that as we increase the thickness of the photoelectrode, more dye molecule get coherently bonded to titanium dioxide surface, and that's why more dye molecule is attached, more light will be absorbed by the dye molecule, and will converting into number of number of electrical photons will be lead to enhance. What is the different way to augment the efficiency of the dye-sensitized solar cell? Nowadays we use a metal-free organic dyes as a photosensitive material in dye-sensitized solar cell, which is generally we use ruthenium dyes, and we know ruthenium is rare and expensive in nature, and due to high toxicity and complex synthesis of this type of dye like ruthenium dyes, research is appearing into the new metal-free organic dyes and to free to natural dyes. The efficiency with the organic dyes has been increased significantly in the last few years. Performance of dye-sensitized solar cell based on natural sensitizer is also increased in recent years. This is the chemical structure of the dye ruthenium complexes. This is the ruthenium complexes. Now I will show you that the dye extracted from this vegetable and this flower can also be used as a photosensitive material, as a photoactive material, or we can use the eucalyptus flower as a photo dye extracted from eucalyptus flower can also be used in the photoactive material on dye-sensitized solar cell. This is a very good thing, because eucalyptus flower or these flowers are easily abundant in nature, and that will be also eco-friendly in nature. That will as a good matter. Now what is the effect of natural sensitizer and dye sensitized solar cell? These are the main points, and this graph shows that for eucalyptus melaleuca leuca legenda, the absorption coefficient is 4.4, and this will give maximum open circuit voltage as well as maximum short circuit current density. As you can see from all these four curves, the open circuit voltage for absorption coefficient 2.24 is 1.764. Here for as absorption coefficient increases here from 2.24 to 3.46, and this with increasing absorption coefficient, open circuit voltage as well as short circuit current density we also increases.